Hello, everybody. Good morning from Vienna, but good day to you wherever you are in the world. Good evening, good afternoon. Hope everybody's doing wonderful today. Welcome to, we've got somebody from Melbourne, Australia saying hello. Please, as always, drop in hellos. Tell me where you're tuning in from. It's always such a joy to see. So happy to be spending this time with all of you. Same to you, Rob. Hello. Oh, I love seeing everybody tune in and say hi. Welcome to day 4 of the Free JavaScript Bootcamp. Ooh, from Burkina Faso. Wonderful. Lithuania. Love to see it. Love to see it. Welcome. Hope everybody's doing great. Let's tune in right away and catch up on what we're doing today. So if you're tuning in for the first time, hi. Oh, hello from Jordan. Wonderful. Hi, Mohammed. If you're tuning in for the first time, hello. My name is Ramon. We're doing a free JavaScript bootcamp in collaboration with Class Central and FreeCodeCamp. If you want to sign up, hello from Turkey. Hi. If you'd like to sign up, you can sign up at classcentral.com. All of these lessons are recorded, so you can catch up very easily at your own pace. You can sign up at FreeCodeCamp to follow along. You will find the forum and Discord links at Class Central and group.classcentral.com. And yes, we've got a Discord server if you want to come chat, help each other, ask questions, and all that good stuff. Finally, as always, please make sure to follow our code of conduct. We expect our students to follow it and make sure that they adhere to it. If you have any problems or anything you need to ask us, please email us at bootcamp@class-central.com. All right. Ooh, look at all these people coming in from Germany, Sri Lanka, Sydney, Sevilla, from Ghana, the Philippines, from Italy. Ooh, this makes me so happy. Let's dive right in and do some JavaScript. Today we'll be doing the fourth and final part of the basic JavaScript section. And if you're tuning in since last time, I assigned quite a body of homework. Again, apologies. I know it was a lot, but we had a long stretch of time between the last lesson and this one, so I thought it would be good to get a whole bunch of stuff done and catch up accordingly. Now, two things. Again, these lessons are recorded. You can watch them at your own pace and be able to catch up accordingly. Second, if you ever get stuck, if you ever have any questions, please ask them in either the Discord or the forum. So, yeah, the homework was to go all the way up until build JavaScript objects. And don't worry, your voices are being heard. I heard that some of y'all were having some trouble with some of the exercises. So here's my plan. I will do one of the exercises at the end during the Q&A, and we'll use that to launch into the Q&A. So don't worry if you're still struggling with some of those. We'll do the core lesson first and then go right into catching up on that one homework exercise and then doing some Q&A. As always, ask your questions. We'll save them up and answer them at the end. If something urgent comes up, I will, of course, try my best to answer it. So today we'll be starting with build JavaScript objects from the basic JavaScript section. And we will hop right in. On the left, you will see the instructions for the exercise, and on the right, you'll see the code that we will be working on, as well as the output console at the bottom. And now, today we're going to be talking about objects. And you've probably heard of objects, you've probably heard of object-oriented programming. Let's focus on objects themselves. Now, before we do anything, I just want to take a look at the code we've got here. We've got a const variable called myDog, which is set to be equals to, and then we've got some curly brackets. And you might have seen curly brackets from if statements. You might have seen curly brackets from functions. But in this context, the curly brackets do denote something a little bit different. When we're using a value when we're using curly brackets in a value, that's where we're talking about an object. And objects are a way of storing data. They're values that store different kinds of representations of data. It's a way of structuring our data. You might think of it as a data structure, as the name of the bootcamp implies. So what does that mean? We've actually already been working with data structures before. Those are called arrays. So arrays are a way of storing data. We store a list of data in a data structure. But objects, similarly to arrays, lets us store lots of different kinds of data. But the difference between arrays and objects, to put it perhaps at a high level, is that where arrays store things in a very structured order, objects don't have a concept of order in this context, but rather they store what are called keys and values, or properties and their values. So what you'll see often, and if we take a look at this cat object down here by scrolling down on the instruction side, you'll see we've got those curly brackets and then a name of a property in quote marks. Sometimes you'll see it without quote marks as well, but we'll get there. Followed by a colon, and then on the right side of that colon, we've got the value. So let's look at that first line. The name of our cat is Whiskers. Once that value and property pair is defined, that key and value pair is defined, we put in a comma and move on to the next property, which is called legs, colon, and then the value to represent it. So a cat has 4 legs. Yeah, followed by a comma. Then we look at the tails. So the number of tails in this context with a colon and then the number 1. Finally, we've got enemies. Again, in quote marks with a colon and the value is an array, water and dogs. Before we start messing around on the right with our dog object, let's make our own object. Const my bird. We're going to make a bird, and we'll need those curly brackets, and then we'll hit enter to create some space, have a semicolon at the end. Quick question Yash is asking that I do want to answer. Is it similar to a dictionary in Python? I would say in concept, yes. I have to admit, I'm not very familiar with Python, but dictionaries allow you to store key and value pairs. And this is exactly the same as in JavaScript, except they're called objects in JavaScript. And we're going to stick to that naming. So let's go back to our bird. And the first thing I'm going to do is have its name be, let's call it chicken. The name of the bird is chicken. Now, you see I've defined the key, then the colon to denote, all right, next up is the value, and then the value itself, which is chicken. Then we'll have can fly. Because yes, not only can you store numbers, strings, or arrays, you can, of course, store any kind of data, like Booleans. Hold on, chickens can't fly, can they? So that'll be false. So there you can see, name chicken, can fly, false. Lays eggs, we'll set that to be true. Now, you know me, I love me to do some console logging. So let's console log my bird and see how it looks. You'll see name is set to chicken, can fly set to false, and lays eggs is set to true. However, notice in the console log, there's no quote marks around these. That's because, as I said before, you can define keys without quote marks. But there's an important rule here. If you do it like this, it can't have a spaces. If you do it like this, then it can. So be very, very careful. And and I would recommend, if you can avoid it, avoid using spaces and key names. With all that said, let's look at our exercise and see what it wants us to do. Make an object that represents a dog called my dog, which contains the property name, legs, tails, and friends. You can set these object property to whatever values you want, as long as name is a string, legs and tails are numbers, and friends is an array. So we'll do that. Let's see. Name will be Geraldine. Notice I did it without the quote marks, but again, you can do it with the quote marks as well. We'll stick with the quote marks just for this exercise. So let's see. Legs will be represented by the number 4. Tails will be represented by the number 1. And friend, I keep forgetting the quote marks, will be an array. Let's see. Fidulais, the dog, and Fido, the dog. So there we've got. And oh, let's console log our dog. Console log my dog. So there we've got an object. Name is set to Geraldine, 4 legs, 1 tail, and it's got 2 friends, Fidulais and Fido. And this is an object. I'll answer a quick question from Helen. Can we use let instead of const for objects? Yes, you can use any kind of variable declaration. Good question. So that looks done. Shall we run our tests? We're passing. We'll do a pat, and go right on ahead to the next one. Because what we can do is access object properties with dot notation. I'll answer a quick question that's also important. Are keys the same as properties? Keys are the ones on the left that define the property name. So we'll do a fuller explanation. Let's save that question for the end. So there are 2 ways to access properties of an object: dot notation and bracket notation, similar to an array. Now, before we do any of this, let's take a look at what we've got in our code on the right. So we've got a const test object, which is an object. I can see that by the curly brackets, made up of 3 properties. The first one has the key hat and the value ball cap. The second one has the key shirt and the value jersey. The third one has the key shoes and the value cleats. Now, before I do anything else, I'm going to console log test object. And you'll see that it's an object made up of those keys and values that we talked about earlier. But the thing about keys and values is that we can access those using 2 different methodologies. One is called dot notation. Test object dot hat. So check it out. If I'm console logging test object hat, it looks up in the object. Okay, I do see you have a property called with the key hat. Let's get the value ball cap. Let's try it with shirt. Jersey. Let's try it with shoes. Cleats. What happens if I do it for one that doesn't exist, like belt? Undefined. Now, the thing about dot notation is that this can also be done with square bracket notation. For example, if I look up with bracket notation the value for the key, and here's the difference, string hat, then it looks up ball cap. If I try to do it without the quote marks, hat is not defined. Why? Because hat in this case does not refer to the key name, but rather some kind of object or object or class or variable called hat, which has not been defined. This is really important to bear in mind. When doing bracket notation, you need to have strings. So the key property is a string. Even if you define that key without the quote marks, this needs to be a string when doing bracket notation. So why is this good? This is good for those times when you need to see a hat wearing. Let's say this key is called hat wearing now. If I want to access this with dot notation, let's give it a try. Hat wearing. What happens? It doesn't work because JavaScript is interpreting as this hat wearing as 2 different things. This is what bracket notation is for. You'll see I'm doing it with strings now, then it works. I've got a question about what if keys are integers? That's totally valid. We'll save it for the end though. But that's a very valid question. Because keys I think they can be integers. We'll get there. So let's restore our object to the way it was. So yeah, we can do dot or bracket notation. What do we got next? Read in the property values of test object using dot notation. Set the variable hat value equal to the object's property hat, and set the variable shirt value to be equals the object's property shirt. And what I'm going to do to make sure that my code is working correctly is console log both hat value and shirt value, adding a line at the end. So right now, it's printing out test object twice, which is, of course, not what we want. For the hat value, we want to use dot notation to look up hat. Frank's asking, can you use quote marks with dot? No. Quote marks for brackets, not quotes for dot. Sorry, I had to answer that question right away because otherwise this gets confusing. So, okay. So we've looked up test object.hat and stored it in the variable hat value. So there we go. Ball cap. But it's also still printing out test object because shirt value is still test object. For shirt value, let's use bracket notation instead. Shirt. So now if we're printing out hat value and shirt value, we get ball cap and jersey. We use dot hat and bracket notation shirt. So far, so good. Let's run our test and see what they say. Oh, let's look at the errors. And if you ever see we see that it didn't work, let's see what it says. Running tests, you should use dot notation twice. So, okay, I should have read the instructions. It says right there, using dot notation. My bad. So let's replace this with dot shirt. Ball cap and jersey looks good. Let's run our tests. And there we go. Pat, pat. Let's keep going. Accessing object properties with bracket notation. Great. We've already known how to do this, so I'm going to skip the explanations and go right into the exercise. Before I read the exercise, though, I like to read what code we currently have on the right. We've got a const called test object, which now has 3 properties. And the first one has a key, an entry with a space, and a value of an entree, and hamburger. Now we've got my side set to veggies, and the drink set to water. Now here's the thing. If we want to access properties with spaces in the keys, that's where we'll really need that bracket notation. So read the values of the properties an entree and the drink of test object using bracket notation and assign them to entree value and drink value respectively. So I can see here on line 9, we've got entree value set to test object, and on line 10, we've got drink value set to test object. Let's console log both of them. Entree value and drink value. And there I can see we are printing out test object twice, which is, of course, not what we want. We want entree value to be the value using bracket notation of on entree. There is hamburger. Fabulous. Some of you might be wondering, can I do this? Can I access this property using dot notation? Unfortunately, no, because there is a space in it. So when we have spaces like this, we want to use we want to use bracket notation. Let's do the same for drink value. That's called the drink. So we'll use bracket notation to do the drink. There's hamburger and there's water. Fabulous. Let's run our tests, see what the tests think. And we're good. Pat, pat. Let's move on to the next one. So, here's another. And, somebody was asking, can keys be integers? Here we go. Let's look at the code first on the right-hand side. We've got a const called test object, which has assigned to it an object made up of 3 key value pairs. First, we've got 12 set to Namath. Sorry, I don't know how to pronounce it. Namath. 16 set to Montana, and 19 set to Unitas. So let's console log that object because we haven't seen one with integer keys yet. Test object. So there we got 12 set to Namath. We got 16 set to Montana and 19 set to Unitas. How do we access these properties? Let's try with dot notation. Test object dot 19. No good. So we can't use dot notation for integers. Can we use it with bracket notation? 19. That works. But it goes further than that. You can also pass a variable to bracket notation because anything in here is a value. So what is that? Oh, Mitch is correcting me. Nameth and Unitas. Thank you very much. How to tell that I don't live in North America. Yeah, so we can pass a variable to it. Let's say we want to access Unitas, right? But we can do that with a variable. So let's const player. Oh, we already have a player number. Player is equals to 19. So we got a variable called player set to the value of 19. Now, if we want to access the key with that number, that can be done with the variable. Oh, sorry. Identifier player has already been declared. That's because on line 13, I already have a variable called player. So I'm going to call on line 8 something else. Let's call it player int for integer. Cool. Let's go back. So we've got a variable called player int sent to 19. And check it out. Now we're printing out the value of test object, the key being the value of player int. So the value of player int is 19. That's why we print out Unitas. If we change that to be 12, that's Namath. If it's 16, we do Montana. Keep those questions coming, folks. We're going to do a Q&A at the end. So player int set to 16, and that gives us Montana. This works with strings too, by the way. Just testing. Let's make a third one called 20. And we'll call it Marco. So let's say we've got a player with a key value of 20. And yes, this can be a mix of strings and integers. Set to Marco. If we wanted to access the player called 20 with a variable, well, since it's a string, we can do the same thing. So on line 6, we defined a new property called 20 with the value set to Marco. We changed the value of player int to be 20 in a string, and then we're console logging test object's value with bracket notation being the value of player int. And Manoj is asking the right question that I want to answer. Why are we using quotes? That's because we're using them in line 9. Remember, it's a string. So even if that string comes from a variable or is passed inside the square brackets, it still applies. Practice this, folks. It'll click once you mess around with it. Do what I'm doing here, but in your own time as well. That's enough of me blabbling. Let's get to the exercise. So set the player number variable to 16. Then use the variable to look up the player's name and assign it to the variable player. So let's look at lines 10 and 11. We've got a const called player number set to 42. And on line 11, we've got a const called player set to test object. And here's what I want to do. I want to console log player. What do we think it's going to be? Right. On line 11, we've set player to be test object, which is printing out the entire object, including my player Marco, which I should remove. So I'm going to delete line 6 and the comma. So console log player gives us the object, which is all well and good, but we want it to be, first we're going to set player number variable to be 16. Let's do that. 16. Great, nothing changes because player is still set to test object. Now, we we're going to use bracket notation, and we want to look up the player whose key is the value of the variable player number. This can be either done with 16, which works, but we want to be using this variable. And because this variable is set to be 16, we can use it in here. Again, no quotes because this is a variable, not a key. And there's Montana. Let's run our tests. Pat. This part's confusing, folks. I recommend coming back to it, watching this video again, and practicing along. It's going to take a couple tries in my experience. Let's keep going. So just like with arrays, just like arrays, objects are mutable. That means that they can be updated to either add or change values. Let's see what that means. Let's take a look. Before I look at the exercise, let's look at our code, as I like to do on the right. Const my dog is set to be an object with 4 properties. Name coder. Oh, I will answer this one real quick. Why was 20 printed without quotes, but the integer keys are printed with single quotes? And that's probably just a quirk of the console. I wouldn't worry too much about this. I don't have the answer offhand. If you want during Q&A, we can go into it, but I would recommend not to worry about it. So let's keep that there just in case we want to come back to it. So we've got a const called myDog, which is an object set with 4 properties. We've got name set to coder, legs set to 4, tail set to 1, and friends set to FreeCodeCamp cappers. So that's cool and all. But here's the thing. You can update properties in objects. For example, let's say we want to change the name of the dog. So my dog, and this can be done with either object or dot notation. We'll explore both. My dog dot name equals to, remember, with the assignment operator, Geraldine. So we can do my dog dot name is set to Geraldine. If we console.log my dog, what does that give us? Check it out. We've got name Geraldine, legs 4, tails 1, friends FreeCodeCamp campers. What's going on? We've modified the value at the property of name to be Geraldine instead. And this can also be done with bracket notation. So instead of saying my dog dot name equals Geraldine, we can do my dog brackets name is set to Georgina. But I don't know why I'm doing names with G. I just like names with G. So we got my dog dot name is set to Geraldine. My dog accessing the property value key called name is set to Georgina. If we console log my dog, you'll see that the name is set to Georgina. So these are the 2 ways that you can update properties of an object. But it goes beyond that. Look at line 6. We've got an array called friends. How do we modify that? So is an array inside an object mutable? The answer is yes. My dog dot friends, right? That's an array. We know that. And we can manipulate that array any way we would another. I'm going to CPU Cortex them. I see your question there. I'm going to leave it for the end because we've covered this before and I want to make sure that we cover as much as we can today. So my dog.friends is an array, which means, check this out. I'm going to cut this and paste it in here. So we're accessing my dog.friends member at index 0. And that gives us FreeCodeCamp campers. Because my dog.friends is an array, we can manipulate it the way we would any other array. Interact with it, pardon me. Which means we can also push to it. Look at it now. So we've called mydogs.friends.push you. And we've seen push before. It adds an object to an array, a value to an array. And if you look at console log my dog now, you'll see that friends is now set to FreeCodeCamp campers and you. So yes, we can manipulate arrays inside objects. With all that said and done, let's look at our exercise. Update the mydogs object's name property. Let's change her name from coder to happy coder. You can use either dot or bracket notation. I'm going to use dot notation. Let's do it. MyDog.name is equals to happy coder. So we're changing the value of MyDog.name, which was previously coder, to be happy coder. Let's run our tests. Looks good. Pat, pat. Let's keep going. So just like we can modify objects, keys in an array. Pardon me, I said that completely wrong. Just like we can manipulate properties in an object, we can also add new properties to an object using bracket or dot notation like we've done for manipulating them. So let's look at our code on the right-hand side. We've got my dog with name, legs, tails, and friends. We've seen that already. So what can we do in order to add a new property? We can just define it by setting it. So let's say my dog, we wanted to have a property called plays fetch that's either true or false. First, let's console log my dog. So we can see it's got all its properties there nicely. Then I'll add a line before that where we'll add that new property. My dog.plays fetch is set to be true. So there you see my dog.plays fetch is set to be true. And if we console log my dog, we'll see that we've got name happy coder, legs 4, tails 1, friends FreeCodeCamp campers, and plays fetch set to true. So now it has 5 properties because we've defined a new one. So that's how it works. It's essentially quite the same as manipulating a property. So let's see what the exercise wants us to do. Add a bark property to my dog and set it to a dog sound such as woof. You may either use dot or bracket notation. Well, we used dot notation before, so this time we'll use bracket notation. So my dog dot bark. Oh, sorry, I already used dot notation. It's a habit. So my dog bark with brackets is set to be a woo. So my dog, the value bark is set to be a woo. Let's console log my dog. Let's see what we get. Name is happy coder, legs is 4, tails is 1, friends is FreeCodeCamp campers, and bark is set to a woo. So that's how we can assign new properties to objects. Let's run our tests. Pat, pat. What do we got next? Okay, so just like we can add properties to an object, we can also delete them using delete and then the property itself. Let's play around with our code here. We've got my dog set with name, legs, tails, friends, and bark. It's got 5 properties. Now let's say we wanted to delete tails. The way to do that is to call delete and then my dog.tails. Now, what we can do is then console log my dog, and let's see what happens. We've called delete my dog tails, name is happy coder, legs is 4, friends is FreeCodeCamp campers, and bark is woof. Notice that tails is no longer here. That's because in line 12 we've run delete my dog.tails, and that will delete that that property from the object. So let's see what our exercise is. Oh, The exercise is delete the tails property from my dog. You may either use dot or bracket notation. Because yes, on line 12, you see we're already doing that with dot notation, but of course we can do that with bracket notation as well. Let's do that just to switch things up. So my dog bracket tails, in quote marks, of course, because it's a string, is now deleted. Let's run our tests. There we go. Pat, pat. Mitch says very correctly, and I want to remind folks, you can't use dot notation if the property has a space in it. That is correct. If the key, that is the name of the property, has a space in it, you can't use dot notation. Keep those questions coming, folks. I am looking at them. I'm trying to, like, the ones that are more urgent, I'll try and answer right away. The others we'll do at the end. And remember, don't stress. This is going to be recorded. So, one great advantage of using objects is that it makes looking things up significantly easier. Instead of reading all of this, I want to dive right into the exercise. Convert the switch statement into an object called lookup. Use it to look up val and assign the associated string to the result variable. So I don't know what the switch statement is yet. I don't know what val is yet, and I don't know what result is yet. That's because I haven't looked at the code yet. So let's look at the code. So we got a function on line 2. We're defining a function called phonetic lookup, and it takes as an argument, as a parameter, one parameter called val. Then in line 3, inside that function, we set result to be an empty string. Then in line 6, we've got a switch statement. If val is alpha, then we set result to be Adams. If val is Bravo, we set the result to be Boston. If val is Charlie, we set it to be Chicago. If it's Delta, we set it to be Denver. If it's Echo, we set it to be Easy. And if it's Foxtrot, we set it to be Frank. Okay, let's see. Then in line 27, it returns that result value. Then on line 30, we call the function phonetic lookup with the value Charlie. Now here's what I want to do. I want to console log, because as you all know, I love to console log. And I want to console log both val and result. So if I pass in Charlie then I'd see that it's set to val, which we knew would happen. And result, because of the switch statement, it says, okay, if it's Charlie, then we set it to be Chicago, which we can see here as result. Let's try with something else. Let's try alpha. It's Adams. What if we set it to be Bravo? And it's Boston. So that's using the switch statement to do that. But as the exercise implies, this can be greatly simplified using an object. So here's what we're going to do. At the very top of our exercise, I'm going to define a new const called lookup. And its value is going to be an object. And in this object, we're going to use keys and values to do the same as the switch statement. And you're going to see line by line how this works. So for alpha, the key of alpha, we'll set the value to be Adams, comma, Bravo, key, value, let's see, Boston. So let's try those two so far, because what's cool about this, and I'm just going to comment out our entire switch statement. So now it's commented out. Now what's really cool about this is that instead of letting result be an empty string and doing a switch statement, we can say let result equals lookup, and then we use bracket notation to look up the value for the key val. So check it out. Let's see what's happening here. It says, okay, we've got our object lookup. We're looking up in our object the property with the key val. And we know val in this case is Bravo. So then it goes into the object and say, okay, let's see if is there one called Bravo? Yes, there is, line 3. So the value for that is Boston. So then it sets it to be Boston, which is cool. Let's keep adding the rest. We've got Charlie. Is it Charlie? Yes, it is. Charlie, the value is Chicago. The value is Chicago. And we've got, let's see what's the next one, Delta and Denver. Delta, Denver. Next, we've got Echo is easy and Foxtrot is Frank. Echo is easy. Is it easy with a capital E? Yes. And Foxtrot is Frank. Now, we've done all that. Our console log still works, which is good. Let's go and try it out. Foxtrot, Echo, easy. Alpha should give us Adams. Fabulous. Now here it gets even better. Now that our switch statement is no longer needed, let's delete it. So what have we got? Let's see. Let result equals lookup val, return result. Let's delete our console log. Let's delete this. So now we've got 2 lines. Let result equals lookup val, return result. Well, first of all, this is no longer being modified. So this should be a const now, which is all well and good. But we can simplify this further, because if we're just returning result, why don't we just return lookup with val and just forego line 11? Look at how simplified that is. So now we've gone from a big, giant switch statement to an object and a lookup that's simplified into 1 line of code. I don't know about you, but I think that's pretty magnificent. And again, don't worry if this doesn't make full sense yet. Come back, watch the recording. It'll make more sense with practice. Mess around with the code like I did. Let's run our tests. Oh dear, you should not modify the return statement. My bad. Yeah, used it to look up val and assign the associated string to the result variable. Okay, my bad. Let's do that. Const result equals lookup val, and we will return result. So even though it's 1 line and it's cleaner, the exercise wants us to keep that variable result. Fair enough. Let's run the test again. Whew, okay, there we go. Pat, pat. We are now 80% of the way done. Ooh, this is interesting. Sometimes it's useful to check if the property of a given object exists or not. We can use the hasOwnProperty method of objects to determine if that object has the given property name. Before we mess around with any of our code, let's make an object. Let's call it const myBird. Let's go back to myBird. And it'll just have canFly set to true. Let me put in my quote marks. And it will have eats set to bird seed. Akatsuku, I see your question. We will get to it when we get to the Q&A. We're almost at the Q&A. We'll come back to this exercise. So canFly is set to true. Eats is set to bird seed. Let's console log myBird. It gives us canFly set to true. Eats is set to bird seed. Now, hasOwnProperty lets us check whether, and that the whether is the important word here, a property exists on an object. For example, myBird that hasOwnProperty set to. Let's try canFly. So we're console logging myBird.hasOwnProperty, and we're passing to it can fly. That's set to true. Why? Because my bird does have a property called can fly. We can see it in line 8. The same goes for eats. Set to true because it has the property eats. But what if we do it for name? That's false. Why? Because my bird does not have an object called, does not have a property with the key name. So that's how that works. Let's take a look at the exercise now. I'm just going to delete my object here and go right into the exercise. Modify the function checkObj to test if an object passed to the function object contains a specific property checkProp. If the property is found, return that property's value. If not, return not found. Great. So if the property is found, return that property's value. If not, return not found. Oh, yeah, let's do that. Simplicity says, is the property each pair of objects? Yes. The property is the pair, and a property is made up of a key and a value. Thank you. Thank you. Thank you. Love that the name Simplicity is asking for a simplified explanation. Okay. So if the property is found, we return the property value. If not, we return not found. So let's start with an if statement. Now let's see, our function checkObj has 2 parameters. One is the object itself, and the other one is checkProp. So the object, if the object dot has own property, and we pass to it checkProp, then we return the property's value. Return object. Now we want to get the value, which means we need to use bracket notation with checkProp. This is good and all, but it's kind of confusing. Let's use some console log to see what's going on here. First, we need an object. Const my bird. Let's bring the bird back. Is set to be. Let's go with can fly set to true. We'll do just one property in this one. It's got a key of can fly set to true. So let's console log check object with my bird and the string can fly. Yash, I see your question. We're going to come back to it because we've got 10 minutes left, and we'll come back to your question in just a moment. So we got console log with check object my bird and can fly. Why we're using bracket notation here is because this parameter, we can't use that with dot notation. You'll see why in a moment. So, oh, actually, instead of can fly, let's change this to be eats with bird seed. So instead of can fly, let's go with eat. So we've got an object called my bird with eats set to bird seed, and we're check object with my bird and eats, and that's returning us bird seed. Why? Because on line 3, if object has own property checkProp, then we return object with checkProp. Now, why are we using bracket notation here instead of dot notation? Well, the property name or the key is stored inside checkProp, which is eats at this time. So if we come back here and we just do object.checkProp, this is going to give us undefined. Why? Because my bird does not have a property called checkProp. Again, the object does not have a property called checkProp on it. Rather, there is a value that is a string stored in the parameter checkProp, stored in there. So we want to use bracket notation to look up that property key, which is eats. But we're not done yet. If the property is found, return that property's value. If not, return not found. So we need an else statement. So if the object has that property, we return that object's property. Else we return string not found. Capital N, capital F. Let's try it. Name. Not found. Phew, okay, we covered a lot in this one. Let's take a step back and look at our code again. So we've got a function called checkObj that has object and checkProp. If object has own property checkProp, we will return that object's property, else we'll return not found. Run our tests. And there we go, pat. Let's submit and go to the next challenge. Okay. Before we do anything else, let's take a look at this one here. We've got a const myMusic, which is an array. An array, and inside that array, there's one value, which is an object. And that object inside that array is made up of 5 properties. Artist set to Billy Joel, title set to Piano Man, release year set to 1973, formats, which is an array with 3 values in it, CD, 8-track, and LP. I think that's like vinyl, right? I'm not very cool, so I don't know. And gold is set to true. Let's look at our exercise, pardon me. Add a new album to the myMusic array. Add artist and title strings, release year number, and a formats array of strings. So first we want to add a new album. We will add an artist and title strings, release year number, and a formats array of strings. Let's break this problem down. First, we need a new album. That will be an object. So let's const new album, we'll call it, set to be an object with 4 properties: artist, title, release year, and formats. Artist will be set to be music person. Title will be set to be cool album. Release year will be set to be 2022. And formats will be set to be an array with an array of strings. So let's put in CD, MP3, Spotify. Is Spotify a format? And let's just say it is. So there we go. New albums with artist, title, release year, and formats. So we've defined our new album already. That's good. But that's not all we want to do here. We want to add a new album to the myMusic array. And add to array, that sounds familiar, myMusic.push. Done push before. We will push to our myMusic array the object new album. We don't see anything because we're not console logging yet. So let's do console.log myMusic. There we've got, let's make this bigger. We've got 2 albums. One is the Billy Joel one, and the other one is my very, very real cool album. So that's how, and notice how I broke that problem down. First, I said, okay, let's make that album, and then let's add it to the array. The instructions are the way around, but there's really no defined order for that. There's no, like, you can break this down, this problem, however you like. I like to focus on one part of the problem first, and then the next one. Let's run our tests. There we go. Pat. Let's go to the next challenge. So. Let's keep going. So here in line 1, we've defined a new variable called myStorage, which is an object with the key car. So it's got one property. This object has one property, which is car. The key is car, and the value of car is an object inside an object. Because yes, we can have objects inside objects. So car is an object with two properties. The first one is inside, which itself is an object with two properties. Glove box set to maps and passenger seat set to crumbs. Then in outside, we've got an object which is set to have one property, trunk set to be jack, which is all well and good. Let's see what the exercise wants. Access the myStorage object and assign the contents of the glovebox property to be glovebox contents to the glovebox contents variable. Use dot notation for all properties where possible, otherwise use bracket notation. So here's what's cool. Let's console log. What's it called? MyStorage. Before we do anything. So in MyStorage, we've got that complicated object. And if we want to look at the contents of the car object, we can go mystorage.car. Now we've got the contents of the car. Then we've got inside and outside. So because car is an object, we can use dot notation on that to access, for example, mystorage.car.inside. Now we've got the contents of the inside of the car, which are glove box and maps. Now, if we want to look at what's in the glove box, we want to do, well, dot glove box. Hold on a minute. We've got an error. Why? Because glove box has a space in it. So we can't use dot notation here, but that's okay because we can use bracket notation, glove box. So we can chain these property calls to go deep, deep, deep inside an object. So glove box content. Oh, sorry, what am I doing? So we want to set glove box contents to be the contents of the glove box. So that'll be, I already did it here. mystorage.car.inside brackets glove box. And that's maps. Let's run our tests. There we go. Pat. So we got 2 minutes left. Let's do one or two more exercises. We're going to be doing accessing nested arrays. As we have seen in earlier examples, objects can contain both nested objects and nested arrays. Similar to the accessing nested arrays, array bracket notation can be chained to access nested arrays. So what does this mean? We can access nested objects like we did last time, but we can also do this for arrays. And we've done this before with matrices, right? With nested arrays where we access, the first element of the first object inside an array. And we can do the same here. Let's see what we've got. We've got a const called myPlants, which is an array. I can see that here in the we can see myPlants is an array. We can see that by the square bracket, and that's made up of two objects. Right. And we can see those objects have two properties. One is called type flowers. And look, there's no quote marks here in the key. That's okay. You can use quotes or not. If you want to have spaces in that key name, use quotes. But if you don't need spaces in the key name, it's okay not to use quotes. So list is set to an array of rose, tulip, and dandelion. Here we've got type trees, and list is fir, pine, and birch, which is all well and good. Using dot and bracket notation, set the variable second tree, which I see here, to the second item in the trees list from the myPlants objects. Again, using dot and bracket notation, set the variable second tree, I see that here in line 20, to the second item in the trees list from myPlants objects. To the second item in the trees list from the myPlants object. Okay, so if we want the second item in the trees list from the myPlants object. It's a bit confusing because myPlants is an array, not an object. The second item in the trees list from myPlants object. So I see. So we want to get this one. We want to get this pine because it's the second item in that list from the type trees. Cool. Let's first get that second object. That's done by using what's the array called? myPlants. myPlants. Cool. Then we want the second object of the array. We already know how to do that with bracket notation and then the index. So the first one is at 0, so the second one is at 1. Let's console log second tree as we go. Console log second tree. If I could spell correctly. There's our object. But we still want to get the second object, pine. So how do we do that? First, we need to get the list. myPlants at object1 dot list. So myPlants at position1 dot list gives us fir, pine, and birch. But we still want pine. So again, we'll use square brackets to access a member of an array and get the second one, which is at index 1. Pine. So with myPlants at 1, then we get the list property, and then we do 1. That gives us pine. And we're done. Pat. I know we're past the hour, but I just want to do one more. This one's going to be helpful, I promise. We're going to do the record collection challenge. Now, this one is quite challenging, and I want to give us time to also do Q&A. So if I don't manage to finish it, at least we'll get the ball rolling. You are given an object literal representing a part of your musical album collection. Each album has a unique ID number as its key and several other properties. Not all albums have complete information. You start with an update records function. Let's take a look at there. There it is. That takes an object literal, records, I see it here, containing the musical album collection, an ID, I see it here, a prop like artists or tracks, that's here, and a value, I see it here. Complete the function using the rules below to modify an object passed to the function. Let's look at our rules. First rule, your function must always return the entire record collection object. We're already seeing that in line 24. That's good. If props is not tracks and value isn't an empty string, update it or set that album's prop to value. Okay? If prop is tracks, but the album doesn't have a tracks property, create an empty array and add value to it. Next, if props is tracks and value isn't an empty string, add value to the end of the album's existing tracks array. If value is an empty string, delete the given prop property from the album. Note, a copy of the record collection object is used for the tests. This is a lot, and you'll notice I read through it and I haven't really understood everything yet, and that's okay. Let's take a look once again at the code. We've got a const called record collection, which is an object with 1, 2, 3, 4 albums in it. Each of them is a key that is an integer. That's all well and good. The value of that property is an object made up of album title, artist, and tracks. Let's see, for the second one is album title, artist, and tracks. For this one, it's just artist and tracks. And for this one is album title. Cool. Let's take a look at what's going on. We've got our function update records, records ID prop and value, and update records, record collection, 5439, artist, and ABBA. Now I'm going to break down each of these into smaller tasks and tackle them one by one. This is called divide and conquer. We will break each of these down into smaller problems and solve them as we go. Your function must always return the entire record collection object. We can see returned records. That's already done. Fantastic. Next one. If the prop isn't tracks and value isn't an empty string, update it or set that album's prop to value. Let's do an if statement. If prop isn't tracks, if prop is not equals to tracks, and value isn't an empty string. Now we did and in the homework, so double and. Value is not equals to an empty string. So if prop is not equals to tracks and value is not equals to an empty string, update or set that value's prop to value. How do we get the album? We get the album by doing records, and we use the ID. Remember, the ID is the ID of that album. Records ID. Then we want to update that property. So records ID prop is set to be value. Phew, okay. That's one part. Let's do the next one. If prop is tracks, but the album doesn't have a tracks property, create an empty array and add value to it. So if prop is equals to tracks, I need to do tracks in quotes, but the album doesn't have a tracks property, so and records ID. Do you know what? I don't want to do records ID all the time. I'm just going to do wait, never mind. Sorry. Ignore what I just said. And records ID, that's the album, doesn't have a tracks property. We'll do that with has own property. So has own property tracks. But if it doesn't have it, so we need to do not here. So if prop is tracks and the album doesn't have the property tracks, then create an empty array and add value to it. So records ID dot tracks is equals to an empty array and add value to it. So it'll be not an empty array. Yeah, no, sorry, it will be an empty array. Records ID tracks dot push value. So we do records ID tracks is equals to empty array and records ID dot tracks dot push value. Okay, that's two of them done. Let's do the third and the fourth. If prop is tracks, another prop is tracks. If prop is equals to tracks and value isn't an empty string. I thought we already did that. Oh no, if it's not equals tracks. See, this exercise always confuses me. So if prop is tracks and value is not equals to an empty string. Sorry, that's 3 equals. It's a strict check. So if prop is equals to tracks and value is not equals to an empty string, what do? Add value to the end of the album's existing tracks array. Okay. Records ID dot tracks dot push value. Cool. What's the last one? If value is an empty string, delete the given property from the album. Okay. If value is equals to an empty string, delete records ID prop. Programar says, my brain hurts. Believe me, I feel you. Watch this again. Watch it a couple times. Go through it a couple times. Trust me, it'll click. And my brain hurts too, for the record. If value knows it's an empty string, delete the given prop property from the album. So we do this one, we do this one, we do this one, we do this one. And then we return records. Let's run our tests. I don't know if they'll pass, but we'll try. It doesn't pass. Okay. And here's the thing I like to do. When I run these, I like to do console log records before and console. Oh. And I'll do a console log records. Actually, let's do a console log records of that album. And then I'll do an after. Console log records ID. Now, people are telling me I should use else if. Let's do it. So if I do that, else if I do that, else if I do this, and else if I do that. Thank you for the tip. Let's give it a try again. That did it, but I still want to go back and look at the code because I want to make very, 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 very sure that this makes sense. So update. So we've got the update records. We console log the record before and after. Let's look at it again. Number one, your function must always return the entire record collection object. Thank you for the tip, by the way, folks. There is returning records. If prop isn't tracks and value isn't empty, so if prop is not equals to tracks, and I should be using the strict equality. So if prop is not equals to tracks and the value is not equals to an empty string, then we update or set the album's prop to value. Otherwise, if props is tracks, yeah, I can see that here, but the album doesn't have a tracks property and the album does not, so not the album has the property tracks, then we create an empty array and add value to it. So we create an empty array here. Tracks is equals to an empty array, and we add value to it. But if folks have suggested, it is absolutely possible to create tracks to be, oh no. Yes, we can, sorry. To create tracks with with value inside it. It's still the same. It's an empty array, and we've added value to it. Let's run the test just to be sure. Still working. Fabulous. Let's go back. Else if prop is 3 equals to tracks and value is not equals to an empty string. So if prop is tracks and value is not an empty string, then we add value to the end of the album's existing tracks array. Records id.tracks.push value. Finally, if value is not an empty string, we delete records ID prop. Note a copy of the record collection is used for the tests. Cool. Enterprise says, can we use only else on the last one instead of if else? Let's give it a try and see what happens. Yes. Hey, good call. Good call. That's nice. I like that. Thank you. All right. Let's give ourselves a pat. Thank you all for your help. Let's go back and look at homework. So let's see what's left of basic JavaScript, and quite a lot is left. Let's see what we've got. Whoa, look at all that we've covered. So wait, Why isn't my record? Oh, I forgot to submit my record collection. My bad. 1 second. Submit and go to the next challenge. Cool. So if I refresh, homework. And I do wish we had gotten to enough time to cover loops. So I think I know I'm eating into our Q&A time, and I'll just stick around a little bit longer. Kiki, don't worry about sticking around for all of the Q&A, but I do want to make sure that we at least cover 1 or 2 loops before leaving homework, okay? So let's do 1 or 2 exercises. I know, folks, I'm delaying the Q&A and I apologize, but I really want to make sure we cover all of this before, because tomorrow we will be covering ES6. So let's talk about loops. Here's the thing. Loops let us define a set of code that will be run more than once. So while that loop is going, it'll keep running that code. Let's look at the example we have here on the left. In fact, let's see, we've got const array is equals to an empty array. We define a variable called I, which is equals to 0. And while I is less than 5, so we do while, and then in brackets, a condition, I is less than 5. Then in curly brackets, we run this code. We push the number I to our array, and we do I++. I want to try out this code, if I may. Let me just copy it and paste it in here. I want to console log our array. So the array is 0, 1, 2, 3, 4. What's going on here? We've got our array set to an empty array. We set I to be equals to 0. Then we define this while loop. So while I is less than 5, we push the number I to our array, and we add 1 to I. So what happens? It gets to the end here and then checks the condition. And we can do that by console logging I. Check it out. First, I is 0. Then it gets to the end, jumps back up and says, okay, is this condition still valid? Is I less than 5? Yes, because I is 1. We do that with 1, get to the end, back to the top. Is I less than 5? Yep, it's 2. Go to the end, back up. Is I less than 5? Yes, it's 3. Is I less than 5? Yes, it's 4. Is I less than 5? No, because 5 is not less than 5. So it does it a total of 5 times, and every time it adds I to our array. So that's all well and good. Let's delete this and come back to our exercise. Add the numbers 5 through 0 in descending order to my array using a while loop. So we're going to do this in a very similar way. We're going to define let I is equals to 5. We're going to add 5, then 4, then 3, then 2, then 1, then 0. So we'll start at 5 while I. Now, if we wanted to check that we wanted to add all the numbers including 0. So we want to do a loop that goes down. So every time I will go down by 1. And then it'll check, is I bigger than or equals to 0? Then it'll add my array.push I. Now, is that done? No, because look at the error. Potential infinite loop detected on line 7. Tests may fail if this is not changed. So, right, what's going on? I'll show you. Console log I. If you look at it, it's scrolling down infinitely because I never change I. That's my mistake. So we need to change I. So after we do my array.push I, we'll do I is equals to I minus 1. Let's console log my array. 5, 4, 3, 2, 1, 0. Let's simplify this code. We know that we can use compound assignment, I minus equals 1, or just like we did I plus plus, we can do I minus. Those are all equivalent. That's done. Pat, pat. We'll do a for loop, and then I promise we're done. For loops are similar to while loops, but well, let's take a look at the exercise and you'll see what I mean. Use a for loop to push the values 1 through 5 into my array. Now, instead of saying while, we'll use for. And we'll have the code just like before, but it's a little bit different because first, what our for loop does is let us define not only the condition as we saw before, but it also lets us define the starting point, the condition, and what happens between each loop. So it's a nice way of shortening our loop definition. You'll see what I mean. Let I is equals to 0 and a semicolon to separate the lines. Then I is less than or equals to 5. That's our condition. We want to push the values. Wait, 1 through 5. Oh, I'm sorry. It needs to start at 1. My bad. So let I is equals to 1. I must be less than or equals to 5. And then between each one, another semicolon, I plus plus. So my array dot push I. Console log my array. 1, 2, 3, 4, 5. Fabulous. Now you see, this is almost the same as a while loop. So let's see, for let I equals 1, that's the starting condition, semicolon, whoops. Then we check the condition under which this loop will continue. I must be less than or equals to 5. And then between each loop iteration, we define a call that gets passed, I plus plus. How would we do this with a while loop? I'm just going to comment out the for loop. How do we do this with a while loop? Let I equals 1, while I is less than or equals to 5, my array dot push I, and I plus plus. This is the equivalent of this. But notice it's in far fewer lines. This is why when doing this sort of thing with like looping through a number, like if you're using a numbers, like you're iterating through a number, it's a good idea to use a for loop. So use a for loop to push the values 1 through 5 onto my array. 1 through 5. Run our tests. We're done. Pat, pat. Okay. Whoopsie. What was I looking at here? Oh, the golf code. Yeah. I was looking at that earlier today. A lot of people put up their solutions, which is really helpful. And this helps me too. Now, let's look at our homework. So the homework, which I will repeat at the end of the Q&A, is to go through everything until the end of basic JavaScript. One more concept that you will need to cover is called recursion. You will learn it here. It will be a little bit weird at first, so I highly recommend ask questions. Ask in the forum, ask in the Discord. If you know the answer, please explain it to your fellow learners. There are more than 7,000 of you in this cohort with us, and it's absolutely helpful for you as somebody explaining, because it'll help you understand that concept even better, I promise. Okay, we covered a lot. Let's do some Q&A. And I know we had a lot of questions today, so please bring them on. Are keys the same as properties? In short, no. Let's take a look at this object here, my dog. This is a property, name encoder. So A property is made up of a key and a value. A property contains the key name and the value coder. This property has the key legs and the value 4. Let's do the, I hope that helps. Let's go to the next question. Can I have a string of objects? A string of, you can have an array of objects. We saw that in one of the previous exercises. But a string of objects, you can represent objects as a string using something called JSON or JSON, JavaScript Object Notation. But that's not covered in this. Oh, I don't think it's covered in this bootcamp. Isn't it bad practice to use keys with spaces? I would say in most cases, you won't see keys with spaces, but it's not unheard of, and the language does allow it. So I would say if you encounter one, use the bracket notation. Is it bad practice? I don't know about bad practice. You just don't see it very, very often, and it's a better practice not to use them. Why was 20 printed without quotes, but the integer keys are printed with single quotes? We answered this one briefly. Let's console.log my dog. What they're talking about is the keys that are printed in the console are represented without quote marks, but if I use a number for a key, then it's printed with a number, then it's printed with a quote marks. And I think it's because this is an integer, but this is really a quirk of the browser, and I wouldn't worry about it. What if an object is in function? Can we still update it? What if that object is in a function? Can we still update it? Yes, we can. Actually, that's what we did in the record collection function. Exercise. Sorry. My dog has declared a const. Should it not throw an error? Yeah, I wanted to cover this because, again, the variable is a const, which means if we try to reassign my dog equals hello, check it out. I'm going to get an error. My dog is read-only. So the variable is read-only. But the value, the object, is mutable, like an array. So we can't change the value of my dog, but we can change the value of a property of my dog, which is what we do in this exercise, I think. My dog.name equals hello. Again, the variable is read-only, but the object can be manipulated. It is mutable. Next question. Can we push values into values that are not arrays? Can we push values into values that are not arrays? Well, push is an array, is a function exclusively for arrays. So you can't, let's try it. I've never done it. Let's see what happens. My dog.legs.push, hi. Check it out. My dog.legs.push is not a function, right? Because legs is a number and numbers don't have the function push. But for friends, that works. Let's console log my dog. Love these questions. Yeah. Next question, please. Why is the delete function not written like the push? I don't know. I'm afraid to say it's just a quirk that came about. So let's see. My delete my dog name. Oops. Delete my dog. Oh, sorry. Square brackets. So now it's deleted the name from my dog. And what you're asking is, why can't we do something like my dog.delete name? It doesn't exist. And I think it's just the way the language was defined. It's a little, it's kind of like type of. Like if you do type of my dog, that'll give us dot name, will give us, oops. I'm going to cut this and paste it in here. There. Type of my dog dot name is string. Type of my dog is object. It's just the way the language was defined, I'm afraid. I'm sure if you look up an MDN, you'll be able to find a better answer than I can provide. In this exercise, which exercise? If the key is without a quote, would it still work? Seeing that the val is always quoted. I think we can do that here. Const val equals legs. Key is without the quote, would it still work? Great. Const val legs. Let's do console log my dog square brackets val. Right. Now let's look at it again. If val is without quotes, would it still work? So if we do val without quotes, it won't work because legs is not defined. There is no variable or object or function called legs. That's why we need to use quote marks here. However, what if my dog has a property called 19? Hello. Then we can look up my dog val 19. Right? Because that's the value, the key is an integer. It's a good question. Thank you. Next question, please. How do we know we don't have to use quotes in the check prop as we actually use quotes? Oh, we already answered that during the thing today. Yeah. How does it know object is my bird? I think I saw that answered in the chat as well. I want to scroll up just briefly. I don't know if you have it there, Kiki. Thank you, MMM, who says, because my bird was passed in as an argument in the function in the place of the parameter object. So let's look at a function again. Function greet name. We've got a function called greet that takes in one parameter name, and we will console log hello plus name plus exclamation mark. That's a 1, not an exclamation mark. If we greet Gerardo, we will see hello Gerardo, and you'll see Gerardo gets passed in as name, and then we do name. But what if we do this with an object? The same thing applies. Check it out. When we added an object to a string, we did the type coercion thing, and then it was all like object. That's because unlike just console logging name, which will show us the object, when we added that object to a string, then it's like, oh gosh, I don't understand. I'm just going to say that this is an object. You'll see object a lot when working with JavaScript. So don't be alarmed if you see it. And MMM and Mitch also said it. Oh no, that wasn't a question. My mistake. Yeah, thank you for the question. That's a really good question. Let's do the next one. What's the difference between the equality operator and the strict equality operator? Yes. Love this one. Console log 1 is equals to 1. Is 1 equals to 1? True. That's what the double equals. But what if the second one is a string? Then we've got true. Why? Because this equality check is not strict. This equality check is saying, well, that's a string and that's a number. I'm going to try my best to make them as equal as possible. So it turns 1 into a string and says are these both the same? Is 1 equals to 1? Yes. But if you want to be strict, that's where the triple equals, or as I like to call it, the threequels comes in. That's the difference between the two. Good question. Let's do the next one. Oh, Wilbert asked the same question. Why triple equals and double equals instead of double equals and not equals? I just like to be sure. When I'm doing equality checks, I want to be 100% sure that they're the same type of value. If there is a space between values, is it okay? What if that object is in the function? Can we still update it? Oh, we already answered the second question. If there's a space between values, is it okay? I'm not sure I understand the question. Can you show me a piece of code that shows it? Like if there's spaces in the keys, you just need to use bracket notation. like you can absolutely leave out the space between the colon. It's just a convention to have that space. What's the next question? Can we append a value into an existing value in a properties key? That said, make it an array. Okay, hear me out. Let's say we want to add a value to legs that turns it into an array. How do we do that? Well, legs is not an array. So let's say we want to add new legs, hear me out, is equals to 6. If my dog, no, if we want to, let's take the type. Oh, I don't know how to check if something is an array. Go real quick. JavaScript type of array. No, that's not what we want. Type of JavaScript. How to check if object is an array. All right, let's go to Stack. Pardon me. Let's go to Stack Overflow. How do I check that a variable is an array? I think I saw r.constructor 3 equals array. Let's try it out. Oh, Class Central has an idea. I think array.isArray. Let's try it out. Console log. Let's say it's an empty array. .isArray. .isArray is not a function. Oh, it is. Oh. Kiki, can you throw me that link in the private chat, please? Thank you. That way I can open it here. Oh, okay. Array.isArray, and then, see, I should have looked it up on MDN. The array.isArray method determines whether the passed value is an array. So it calls array.isArray, and then we give it the array. Good. Okay. Hear me out. Let's try it out. Array.isArray. Empty array is true. Okay, cool. Good to know. So if my dog.legs, we want to check if it's not an array. Array.isArray. Dog.legs. Then my dog.legs is equals to an array with my dog.legs, comma, new legs. So that's how I would append it. Else, my dog.legs.push new legs. That's how I would do it. First, check if it's not an array. And if it's not an array, we turn it into an array with the value as the first member of the array, and then the new value as the second member of the array. That's a cool question. Next question, please. Can I name a key with 2 values or spaces between them? Can I name a key with 2 values or spaces between them? Can I name a key with 2 values? No, you can't have a key with 2 values. Each key must have 1 value. If you want to have a key with more values, that's what an array is for. Second question, can a key have 2 spaces? Yes, it can have 3 if you want. Have 4. Check it out. Have 5. It can have 6. Console log my dog. There, see? You can make it. I mean, I don't recommend it, but you can. That's the great. That's the great and terrible thing about programming. You can't, like, everything is up to your power. Computers just know how to. Computers aren't like smart enough to be able to determine, should I do this? It's just like, well, I will if you tell me. Good question. Let's do the next one. Oh, can you have objects with no properties? Empty objects. Oh, yeah, totally. Let's do it. Console log. Nope, this one. This is an object. Const, let's do it here. This is an empty object. If I console log my dog, it's an empty object. That's how you do empty objects. Great question. Let's do the next one. If you have a const that's been defined as an object with multiple property and then delete all of the object's property, the const would then just be an empty object. Yes, it would. Let's do it. Delete my dog.name. Delete my dog.legs. This sounds really, really mean. My dog.tails. And delete my dog.friends. Let's console log my dog. It is now an empty object. Great question. I love it. Can the property names with spaces in them be single or double quotes when you're using bracket notation? Yes, it can. Let's give it a try. Console log my dog name. There you go. Single quotes totally works. Next question. If we do not pass any parameters into the function, do we still need to use return keyword? Those are separate concepts. So like if you let's say we have a function called function. Oh, the greet one that I had before, name. Console log hi plus name. Greet. That's just going to do a console log. Oh, sorry. Gerardo. Hi, Gerardo. But what if we console log the return value of greet Gerardo? First, we called greet Gerardo, which console logs hi Gerardo, but then we console log its return value. Since it doesn't have a return value, the return value of greet is undefined. Weird, right? But yeah, those are separate concepts. Let's do a couple more questions. Is array my does strict equals true or not true? So, that's a good question. So console log array is array. There's no comparison going on here. We're just returning a Boolean value. So we're not doing any comparison as strict equals or not. I hope that makes sense. Can you delete various properties in one line of code? Oh, wait. Sorry. Going back with the return function, censor. Thank you. Of course. You have if you're ordered to go get some apples to the store, you need to return with apples. Otherwise, you return with nothing. This example was so good. Go check out last week's session. It explains that whole return thing really well. Let's go back to can you delete various properties in one line of code? Delete my dog.name. Essentially, no. But if you want to put lots of lines in one line of code, which I don't recommend, but you can do it, you can use the semicolon. You can have it do multiple lines of code in one go. It's technically calling 2 lines. So the answer is no. Is it possible to run lots of lines of code in one go? Yes. Oops, sorry. How do we copy an object's properties to another and not mutate the original object? Hey, that's cool. That's a good question. Const my bird is equals to an empty object. So what you're wondering is, how do we copy? Well, my bird.name is equals to my dog.name. That's how I would do it. Because remember, we're just my bird. You see here, name coder. My dog is still named my coder. What's going on here? we're just querying the object for its value. We're not removing it. So we're not mutating the original object. It's a good question. I'm going to take this opportunity because we're well over time and I want to respect everybody's time. I want to go back real quick and do one exercise, which is the golf code. This was a tough, give me 1 second, folks. I just need to take care of one thing. I'm really sorry. I'll be right back. Hey, folks, sorry about that. Yeah. So let's see what we got. Strokes and return. This is live. Yeah. Just making sure my dog doesn't get fed twice. So what do we got here? In the game of golf, each hole has a par, meaning the average number of strokes a golfer is expected to make in order to sink the ball in the hole is to complete the play. Depending on how far above or below par your strokes are, there is a different nickname. Your function will be passed a par and strokes arguments. Return the correct string according to this table, which lists the strokes in order of priority, top being highest to bottom being lowest. So if we do it in one stroke, we get hole in one. If the number of strokes is less than par minus 2, then we get an eagle. If the number of strokes is par minus 1, we get birdie. If it's par, then we return par. If we do par plus 1, we return bogey. If we do par plus 3, then it's double bogey. Otherwise, go home. Par and strokes will always be numeric and positive. We have added an array of all the names for your convenience. That's very nice. We can see here hole in one, eagle, birdie, par, bogey, double bogey, and go home. Now I'm going to break this down in order of priority. So let's see. We've got a function golf score that takes two parameters, par and strokes. And one thing I'm going to do, because I like to, is console log that. Console log golf score. Not golf score, sorry. Par, comma, strokes. I'm sorry. 5 and 4. Fabulous. Yeah, I can see that on line 12, it's being called with 5 and 4. So we've defined the function in line 3, and we call that function in line 12. And we're calling it with the lines golf score 5 and 4. So we console log par and strokes, and we return change me. Fabulous. So let's start with the first one. If the strokes is 1, we return hole in 1. So if strokes is equals to 1, then we return, and we want to return hole in 1, which is names at index 0. Let's console log the return value of that function as well. Right now it's changed me, of course, because the number of strokes is 4 and we haven't accounted for that yet. So let's call it with 1. Check it out. It does hole in 1 because if strokes is equals to 1, we return names at 0. Fabulous. Let's do the next one. Else if, we'll do an else if the number of strokes is less than par minus 2. So strokes is less than or equals to par minus 2. And we return eagle, which is names at index. And I'm going to go back down here and try it out with, let's see, the par is 5. The number of strokes is 1. That gives us hole in 1. If I do it with 2 strokes, it's eagle. If I do it with 3 strokes, still eagle because it's less than or equals to par minus 2. Par is 5, so 3 is less than or equals to 3. But if I do it with 4, that's change me. So we'll need another else if for the next one. Else if, let's see, par minus 1. Okay, so if strokes is equals to par minus 1, and we do, what is it? birdie, which is birdie. Okay, that's the third one. So that's return names at index 2. Yep, perfect. Next is strokes is equals to par, and we return par, which is the fourth one, named at index 3. Let's try it out. So 5 is equals to 5, it's par. What if it's equals to 6? We're still at change me. We'll do another else if. Else if strokes is equals to par plus 1, we will return bogey, which is at the fifth one, yeah. Names at 4. Here we go. Bogey. Next is double bogey, which is for par plus 2. Else if strokes is equals to par plus 2, we will return double bogey, which is index 5. And finally, so let's test that. So that's double bogey. And then for anything bigger than par plus 3, it's go home. So we'll do an else return. Oh, not go home like that, but we want the index line 6. Names at index 6. Try it out. Go home, we'll do 100, go home. But what if the par is 101 and it's a birdie? As strokes is 1 less than par. We can remove line 23. You saw I broke it down line by line. Let's run our tests. And it works. Pat, pat. Okay. That's all done. I think we don't have any questions left. Am I wrong? We have one left. I think we're good for today. Oh, okay. Enterprise asking, are you plan on teaching more courses after JavaScript? Never say never. I will continue doing cohorts of these boot camps. So we'll see. I would love to. Stay tuned. All right, folks. Let's call it a day. Let's look at the homework one more time. So tomorrow we will be starting with ES6. So your homework is to do the rest of the exercises in Basic JavaScript. Once again, if you've got questions, go to group.classcentral.com. Please also answer questions. If you know the answer, collaborate. I'm telling you, one of the best ways to learn is to teach. That's how I've learned JavaScript. Also, there's a Discord channel. You've seen the link pop up. You'll also find it in the Class Central dashboard. Go and check it out. Super valuable. Finally, if you've got any concerns with the bootcamp itself, if you have any code of conduct violations to report, please email us at bootcamp@classcentral.com. This email is not for questions about exercises or understanding. That's what the forum and the Discord are for. This is just for issues with the bootcamp itself. Okay, so I think we're going to call it a day today. I will say thank you all so much for everything. Thank you so much for following along. Wish you the most wonderful day, the happiest of learning. And remember, tomorrow we will start with ES6. So with all that said, I will say goodbye. Thank you so much for participating. I'll see you tomorrow. And just have the best day.